I think to do well in parametric equation, just need to understand what is the idea of parameter. Okay, you stay in a house, right? House got housing address or not? Your house got housing address, right? If I give you which unit, which number, you know exactly where to find your house, right? Parameter is like that. Everything on the graphs, right, has every point on the graph correspond to a parameter. Okay, I repeat, every point on the graph corresponds to a parameter. So for this question, let me just explain. How it works is very simple. So essentially, what happens is if I ask myself when t equals to 0, right, because my t is from 0 to 2 pi, t equals to 0, what's my x value? I put inside here. Then y equals to sine 0, so this will be 0 lah. Then cosine 0 will be 1, so this is 2 lah. So t0 is 2, 0. Okay, so if you ask yourself, so I put t0 here. Let's say this is 0. So it'll be 2, 0 lah. You see that? Just do that, okay? Okay. So do I just test t0? No, right? From this domain here, what they're saying is I test from 0 to 2 pi. I replace from 0 to 2 pi. So we need to say I'll continue t equals to 0.001, so on, and until 2 pi lah. Okay. So what kind of graph will I get? Is that 0 to 2 pi will be rough. 2 pi is about 6 point something. Don't know what is it. 2 pi. Okay. So you understand what I'm saying? Until 6.28 here. So I just trace it out. Understand? So once I trace everything out already, what will happen? It will become this graph here. Understand? If I trace from 0 to 2 pi, exactly 0 to 2 pi, I will trace out this graph here. Understand or not? Okay, so that is the idea of parametric equation. Every single point on the graph would have a parameter. Every one will have one parameter corresponding to a point. Sometimes a few lah, but doesn't matter. Just basically from this gesture, we know every point on the graph will have one. It's a housing address parameter. Okay, so if I want to do this question using GC, of course, because we don't have decimals, you go to function, then you put this parametric, right? Then you go to this guy here. What you do is you put 2 cosine t. Then you put like cosine 2t. Then you put this guy here as 2 sine 2t. Sine t. Then cosine 2t. Okay. Now you have to be careful. This happens to be GC's default. GC's default is 0 to 2 pi. If not, you need to change window setting. Okay, your window, you need to make sure it's 0 to 2 pi. So you just make sure that this guy is 0 to 2 pi. 0 to 2 pi is this guy here. I will suggest you put this 6 to 3 lah. Okay. Okay. Just 6.3. Okay. Or 0 to 2 pi lah. But because if you put 2 pi exactly, when you key in 2 pi, later they have some problem. Usually I'll just say put 0.6.3. Then this is the graph here. Then you just zoom box. You zoom box first. The question is, how do you actually find all these points here lah? Firstly, what I'll say is you just press trace. Try 0 first. 0 is here. So I will suggest that trace, then you can put like pi over 2. Then is this value here. You can trace, you can put pi here. Then you can put like 3 over 4 pi, 3/4 pi. It will be trace, you put 3/4 pi. I'm just trying all these different values. So 3/4 pi is here, pi over 2, then 3 over 2 pi and so on. I will just check lah. So I roughly know where are the values at. Okay, so how? So of course, sometimes you guess and check, you may not get the point that you want, right? So what do? Understand this, this juncture, if I want to find any point on this axis here, this is when y equals to 0, right? Alright. When y equals to 0, what you need to find is find the housing address, bro. Just find the housing address. So when y is 0, you know that this is sine 2t. This will be cosine 2t, right? Cosine 2t equals to 0. Why we equate this to 0 is because we want to find the parameter, or rather is on the x-axis. So y is 0. Then from here, I know sine 2t is equal to 0 or cosine 2t equals to 0. So then now the question is you solve this trigo equation secondary school. But just now we already test but anyway we test. Usually when it comes to trigo, I will suggest you always parametric equation, always put these two value in first. Okay, the boundary, the extreme value. So from here, from GC, right, when you trace 0, you get this point. So you know this point here is t equals to 0. Okay, and this point is 2, 0 from the GC. So then you just now you practice, you trace 2 pi, right? 2 pi will be still this point here. The same point, but you don't need that. So you trace pi, you get this point, negative 2, 0. So you know that this point is negative 2, 0. Okay. In fact, when you solve this, right, you will get this 2t will just become 0 pi, 2 pi, 3 pi, and so on. Then 2t here will be pi over 2, 3 over 2 pi, and so on. So this will be t equals to 0, pi over 2 pi, and 3 over 2 pi, 1/4 pi, 3/4 pi. You see this pi over 2 here? Sine t, Sine t, not sine 2t. So this is sine t. So this is t, So we want from 0 to, so it's this guy lah. Because we want 0 to 2 pi, do include 2 pi and 3 pi. Pi over 4 in the middle lah. Okay, so that's it. So this guy will be 0, 0. Okay. Now always wise to label the parameter. So like this is t0. This is pi over 4. Okay. For now, you are not dealing with very difficult parametric curve yet. So when you are doing like, actually, yeah, taken out of syllabus already, so you don't really need to worry about it. I think area under graph, you don't even have parametric equation, so it's fine. So then this guy will be trace. Just now pi was here, right? So this is a pi. It's always good to just put the parameter there. Okay. So if this is 0, t0, right? Then this is pi over 4. Then you will guess what is this point here. You can also let x be 0 lah. Then you try and solve it. Yeah, so this is pi over 2. 0, negative 1. Pi over 2. So if this is 0, this is pi over 2, then this would likely be 3 over 2 pi lah. We try. Or, yeah, 1.5 pi. So trace 3 over 2. There you go. Easy game.